All right. Yeah. Das könnt ihr machen, wie ihr wollt. All right. Welcome, everybody. It's a pleasure for me to have you here for our panel on trustworthiness of human-centered robotics and AI. We'll see if we can discuss against the rumor and mumble around us. And we will start off with the quick introduction of our panelists and their perception of what trustworthiness means in robotics. But do start writing down or thinking about your questions, because we will make sure that there is time enough for you to answer them. So it's a pleasure for me to welcome Angela Scherlich from TUM, Gita Coutinho from LMU, Brian Gerke from Intrinsic, and Stefan Leutenegger also from TUM. We ask each of these panelists to briefly introduce themselves, but also to kick us off with their perception of trust in robotics. And Angela, if you want to start.
Okay, great. Welcome, everybody. My name is Angela Scherlich. I'm a professor at TU Munich for safety, reliability, and performance of learning systems with a focus on robotics. And before that, I was 10 years at the University of Toronto. I have also another role. I'm on the board of directors of the Munich Institute for Robotics and Machine Intelligence, MIRMI. And yeah, I work with robots every day. Robots are moving in our labs every day. So if I talk about trustworthiness, the first part is we want to get robots closer to humans. But if we get them closer to humans, we have to guarantee that this is safe, like that we do not harm humans in the process. And that also relates to Asimov's laws, right? Do not harm a human is one of the key kind of rules for building a robot. And so safety is critical if we get robots closer into our human-centric environments, meaning our homes, a fair like this, or hospitals. And so on the other hand, if we deal with these complex environments, we need machine learning. There's no question about this, right? I mean, to understand the environment and have a semantic understanding, we need machine learning. So one key for me for trustworthiness in robotics is to ensure safety despite the fact that we incorporate more and more machine learning into those robot systems.
Great. We'll get to how we're going to get there in a moment. Thank you. Gita.
Yeah, welcome also from my side. My name is Gita Coutinho. I'm a professor at LMU Munich. I'm head of the chair for mathematical foundations of artificial intelligence. I'm also one of the two directors of the One Munich project where this panel is associated with. So I'm the director from the LMU side. Sami Haddadin is the director from the TUM side. And I'm also one of the two directors of the Konrad Zuse School of Excellence in Reliable AI. This is also a project joined with TU Munich, and my partner on the TU Munich side there is Stefan Günnemann. Now, from my side, since I work on theoretical foundations of AI, I know that there are still major problems with reliability, with trustworthiness. And from my research, what I see is that only with a deep understanding, we can actually really ensure that we can trust the outcome, that we also have error bounds for the outcome, that we know about the uncertainty of decisions. And so from my perspective, if we talk about trustworthiness in the sense of embodied AI in robotics, this is a direction which is very important for me, that we have a deep understanding, in particular, when, if it's possible, a theoretical understanding, so that we know exactly what happens, also in the sense of safety, security, also responsibility, so that we can also explain actions of the robot.
Great. I'll take that keyword on explainability. We'll come back to that, Gita. Brian.
Hi, everybody. Happy to be here. My name is Brian Gerke. I'm with Intrinsic. Personally, my background is I've basically built my career around developing open platforms for robotics. So I've been developing open source software. Most recently, I've been leading the team that's been the core developers of ROS, the robot operating system, which you may see running a lot of robots around here. And building on that experience, I'll say that to me, a key aspect of building trust is being able to inspect the system. And so I'm going to argue for having openness wherever we can throughout the stack so that if you want to understand how the system works or understand why it's trying to do something, you should be able to look at what the robot, how the robot was actually developed and inspect and even potentially modify that system to meet your needs better. And that way, that's a better way for you to trust it.
Great. Thank you. Open source, noted. Stefan.
Okay, so Stefan Leutenegger, I'm a tenure track professor here at TUM. My research area is sort of at the intersection of spatial AI, so the 3D and semantic understanding for robots then, and to actually use that in control, in navigation for certain applications. So I'm really a sort of person that applies machine learning and AI to robotics. And so answering the question about what reliability or trustworthiness means, I think a lot of good things have already been said, but just to maybe add to that, I think it's of course important that we have a certain adherence to established ethical, moral and societal standards, that the behaviors are reproducible, that doesn't do one thing at one time and then a completely different thing at another time. And yeah, just to add to the sort of introspectability that Brian was also mentioning already, I think in an ideal world, we'd be able to also query a robot, like why did it take a decision? So not just at the level of looking at the code and understanding the algorithms, but really at runtime as users that we are able to query, to introspect what's going on. Also things like what sources of information have been used to come up with a certain answer, a certain decision. And I mean, ultimately, I think trustworthiness has a lot to do just simply whether people trust a system or not. So that's the final sort of decision to be taken there. Do we get people to trust robots?
Seems to me a lot of the vendors here are trying to build trust right now. So that is certainly true. People are an important element here. You mentioned one thing that in our pre-conversation, that you are sort of worried that it is difficult to think of all the input channels and the different perceptions and information that is needed, and then really get to a point where I can trust that those are taken correctly and act on correctly. What is your experience? Where's the biggest challenge there? Where do you see the path to a solution?
Yes, I think when we're looking at actual development, also real efforts of developing, for instance, self-driving cars, a lot of the challenges we see is at the perception side, in my opinion, that things do go wrong, and there is an expectation perhaps from industry, from people, that we should just come up with guarantees. We should be able to guarantee that, let's say, a robot sees every pedestrian, right? And I just want to challenge that a little bit, because I think it's in the nature of the problem. It's impossible to do. It's maybe a bit of a controversial statement here, but it is a really hard problem, and people are also not able to guarantee that they will always see everything. So I guess I just want to warn a bit that probably we as a research community, we're not going to come up with guarantees here. We are going to be able to perhaps provide statistical evidence that we can hit targets, but I guess there's a bit of a question also to Gitta and others that are researching in this field. How do we think we can move forward? Is my analysis correct or not?
I was just trying to play that ball from the practitioners over to you, Gitta. As a mathematician, that's your job, hard problems and giving guarantees. So how do you guys go about that?
Yeah, thanks a lot for the question. Thanks a lot for the challenge, Stefan. So, typically in mathematics, what we do is, we go into a model situation, which is as close to reality as possible, and within the model situation, then analyze the AI. We aim to determine how it generalizes, for instance, to unseen data, depending on the data it has been trained on. So in that sense, within the model situation, we can then get, let's say, 100% guarantees, error bounds. Then certainly, the question is how to transfer it to practice, and that's the question of the model, how good the model is. But another aspect I would also like to bring up, and I think this was something which you already want to mention concerning explainability, because there are also methods to check how sensible a decision was, for instance, of a robot. Explainability is a very active area in AI, and it asks the question, I have an AI system, maybe also embodied AI, and I would like to know a decision was reached, maybe an action was done. Why was it sensible and what was it based upon? Why did the robot reach that decision? And from my perspective, this is something where we can check actually how reasonable a decision was. And as said, I mean, in communities like, for instance, imaging sciences, explainability approaches are already very standard. I think in robotics, there is still some way to go. But from my perspective, that would be also something where you could check how, let's say, reliable and trustworthy a robot is. Although, and I agree with you, Stefan, in every situation, having 100% guarantees will not be possible, only in model situations, but at least then in realistic situations, you could check it.
Angela, you mentioned that you're dealing and working with the robots on a daily basis in the lab. Have you seen the problem that Stefan mentions, and that you know, in particular now that you started to use machine learning within the systems, that unexpected things happen? I mean, for me as a layperson in interacting with robots, certainly a lot is unexpected, but even for you, I would think some are. How do you deal with that? Do you know how to get the explanation? Where do you see it's outside the bounds?
Yeah, so the method we use for giving some guarantees for real robot systems still rely on probabilistic machine learning methods usually, right? And they have definitely big advantages in certain cases because they can tell us where we don't have data and where we should be more careful and where there may be more uncertainty in the behavior of the robot because we haven't explored that type of behavior before, for example. So those methods are very valuable. They still rely on a number of assumptions. While they are applicable to real robots, we still have to check if these assumptions are actually true in practice and while the robot runs. And I think this is also an open area where more research can happen, that you online check if assumptions actually are true. And that is not that difficult actually to do, and that could add into the explainability as well. So, yeah.
If I may, I wanted to build on that and say that it's even given the ability to prove that it's working, I think we still need a way to represent that to the users, right? We still need a way to represent what is the robot doing, what is it intending to do and now, I mean, really, if we think about robots getting out in the world, autonomous cars, like we're all users of robots at this point, whether we want to be or not. Sometimes we're unwilling users of robots if they're out in the world interacting with us. And I think we have quite a ways to go in representing what the internal state of the robot is to the world, right? We see robots all around here, and honestly, unless you happen to have built that exhibit, you probably don't know what that particular robot is doing, right? You don't know what state it's in. And I'm reminded of an interview with a commercial airline pilot who was talking about how in the cockpit of a modern Airbus airplane, it's not that uncommon when the airplane does something unusual that the pilot says, I wonder what the airplane is doing right now. And I mean, that's kind of worrying, right? Because these are trained professionals in a like what we think of as a reasonably constrained environment. You would think that's probably easier to represent what is happening, and yet we don't appear to have the right approach to presenting that information to the users who need it.
Let me follow up on that then. So you mentioned open source is at your heart, and that's where you're building. How would that help with what you're trying to do? Because only because the code is open source, it doesn't help us to know why did it do what it does, and does the code itself is enough, or do you need access to the data in the way that Angela mentioned, that if you have sparse data and you don't know what gets imputed or whatever inference is made?
No, so I mean, making something open is not magic, right? That doesn't automatically accomplish all your goals, including achieving trustworthiness. But I think it is an important step. I think about, for example, probably many people here use the messaging app Signal, and it's open source, which means that it can be inspected, and that I think causes more people to trust it. I would guess even those of you who use it probably never looked at the code yourself, but your knowledge that it could be looked at, that you could look at it if you wanted to, is going to increase your trust in that system. So I think that's a first step, but that's not enough. We have to go further and then actually build these systems in a way that the user experience is accessible to the people who need to get the information out of it.
Do you think that the average users of these systems care about the open sourceness?
I do. I think the average users should care. I think that they should have a preference for using systems that are open and are modifiable. And I think that having the ability to essentially have like a sense of authorship in a system, being able to modify its behavior to better meet your needs, I think that should be an appealing feature. That should be something that, as companies are developing products, I'm not an ideologue about it, right? I'm not saying that everything everywhere must be open, but I think there are certain parts of the technology that we're developing where we can serve society better by having those things be open.
For sure. I mean, as scientists, we've subscribed to those standards, for sure. But Angela, incorporating with industry that you have done in the past, where do you see the conflicts with respect to that? That systems can be so open. There's always worry, I guess, that they can be more easily manipulated if the code is open. That's currently in the discussion that we see around OpenAI, that they don't want to open up everything so that they can safeguard against intruders or workarounds. What do you think? Where can be the fine line that we need to walk?
That's a good question. It goes back to this interface between kind of the human and the system, right? Of course, companies need to also think about how they actually make money, and some make money by closing their systems such that they cannot be easily copied. So I think there's a fine line, but I don't think that needs to jeopardize trustworthiness if some parts may be closed, as long as the interface is designed in a way that allows getting insights. But I think one important thing for me is also trustworthiness is really this interface between human and the machine or human and the robot. And that has been very often neglected. And this goes from the development where you aim, where open source is probably, at least the most transparent way of interfacing between code and the human, all the way to the robot on like a semi-automated car that interacts with the driver. And I think these interfaces, at least in robotics, we have very often neglected and are really at the heart of the trustworthiness. And so I think it's worthwhile to really think about strengthening efforts around that.
Great. I do want to see if the audience has a question here for our panelists. And I'm sure the technic folks can hear me and organize a mic. If not, you get mine. Yes.
Can a robot autonomously acting in an open environment be trustworthy if it doesn't understand what it's doing? I think it's. I think the question about introspection, if you really want to have trustworthy robots.
Wir bräuchten noch ein zusätzliches. Were you able to hear that?
Yeah.
Okay.
Well, so can a robot be trustworthy if it doesn't understand what it's doing? Yeah, I mean, that suggests that so if no, then are we aiming for like fully self-conscious robots in order to be able to trust them? Yeah, you want to. So yeah, Michael's saying that it should be able to answer questions about what is it doing, why is it doing those things. I kind of hope that's not strictly necessary because that still strikes me as very, very hard. I think we should aim for that, but I think in the meantime there are concrete steps that we can take that are going to improve our ability to make systems trustworthy. at least just by representing what they're currently doing. Like to take a really simple example, at the intrinsic booth over there, we've got a cell running with 2 robots that are assembling parts of a car, and normally you would see that and there would be absolutely no interface at all. But because of the way we architected the system, we can show you the behavior tree that's executing. And so as a casual observer, without having any knowledge of robotics, you can walk up and look at it, and you can see what state it's in, and you can get an understanding of what's happening next, right? It gives you a sense of predictability, like Stefan was saying, so you can have an expectation of what the robot is going to do. It's definitely not getting all the way to a cognitive system, which I think you're describing, but I think those are steps in the right direction.
Yeah, I think I agree with that, but I also agree with Michael that I think it gets harder and harder the more open-ended your environment becomes and the more open-ended your tasks become, right? So as soon as you can somehow constrain both of these, we can simplify the problem to an extent that makes introspectability more straightforward. So the question is, what are we going to do in the more open environments? And I also don't know, but I think it should be something that we aim for, that we can introspect in some way or another. I would even argue that actually now with things like the large language models that we have, perhaps that provides a certain interface into the robot's brains to give us answers that actually anyone can understand. You don't even have to be a programmer or an expert in robotics to see what's going on. And as long as the answers are plausible and consistent with the robot's behavior, then maybe that's what we need. Yeah.
Is that all we need?
I want to add something. I want to really challenge the connection between explainability and trustworthiness. I don't think one follows from the other. And I actually don't think explainability is necessary for trustworthiness. We trust people and we cannot explain why they do some decisions, and we still trust them, right? So I think there's a lot to be said about predictability, reliability, functional safety that generates trust. I don't think that explainability is necessary for trust. That's just putting some other kind of opinion out there.
Looks like Gita wants to.
Yeah, so maybe I can also
Okay.
comment on that a bit. I mean, I might disagree a bit. So from my viewpoint, I mean, trustworthiness also requires explainability, and maybe commenting to what Stefan just said, I mean, in the explainability community, there are already approaches where large language models, for instance, are now trying to be integrated, and the vision there is that indeed you communicate with an AI, you ask questions, how a decision was reached, and you are able to basically understand what aspects it based its decision on. I would also like to bring something else here on the table, which are legal requirements. So the European EU Act actually also requires the right to explanation besides algorithmic transparency. So in some sense, I mean, explanation will be required for AI technology to a certain extent. So, and therefore, I think it is something we all need to think about. And as said, I mean, to conclude, for me, I mean, for trustworthiness, this is an essential ingredient.
This is an interesting aspect. To which extent can we learn from human-to-human interaction? And does that hold for the machine, right? But I think I get your point, Angela, when you said that, because I do think you might need it when trust was broken, right? I mean, the problem is it takes a long time to build it, and then the car goes off the rail or it doesn't see the human. But if you then have a good explanation why that happened, maybe that's the way to safeguard the trust, right? That could be an element of it. So I don't think they're entirely independent, but I do agree that it's not necessarily a necessity to get to trust in the first place.
Right, and you're not talking about the failure cases and then generating trust from failure cases. We want to avoid the failure cases in the first place, right? That's should be the priority first, before kind of like really making these systems better and predictable before, and reliable, before thinking about the failure cases necessarily. Yeah.
So Brian, as someone in practice, is that realistic that we can sort of make it safe and trustworthy before we even get out into the real world? It seems like the world is too complex and we will still need to learn, to me. But and if we can do it up front, what need to be in a regulation from a practitioner's point of view so that you guys can move forward?
Yeah, so I mean, the way that we approach it in practice is testing, fundamentally, right? We're going to test in all the cases that we care about. We're going to test with the user sets that we care about. And we're gonna have an approach to modeling risk and mitigating risk to the point where we can make a commercial decision that we're comfortable putting out a given product in a given environment. It's frankly never going to be perfect, and in practice we're not aiming for that, frankly, because we know, as Stefan said, that it's frankly in the more complex scenarios it's unachievable. And so what we want to do is understand what is the risk we're willing to tolerate, and can we test enough that we can confirm that we've mitigated to the point where we're comfortable with it. To the point of regulation, I think there's a benefit to industry from having experts in the field who are working on regulatory standards that we can adhere to, because especially smaller companies, they don't have the resources to really think very deeply about this. And so, to take an example that you may or may not like, GDPR has had a huge effect across the industry, in part because it has given everybody the same bar to hit, right? It's given a clear guidance to every company in the world. If you want to do business with the EU, here's how you're going to approach privacy. And that's established a level playing field in a sense. And so I know it's unusual to hear someone in industry asking to be regulated, but what I would say here is that if there can be an agreed upon effective standard, then what you will find is industry will by and large adopt it.
Lately, we hear more and more from industry asking for regulation. So what, in your minds, what do you think are core elements that should be part of such a regulation? Maybe starting with you, Stefan.
Yeah, I mean, maybe just connecting to what Brian has already said. I think certain tasks that we are trying to solve here, they're so complex that we can only go back to statistical testing. So I think that's probably the starting point for some of the more challenging applications we're talking about, that we are demanding statistical tests. Now, that is in itself also very difficult to achieve, because, for instance, what happens if you change one line of code? Are you going to redo all the tests? I don't know, but to some extent, I feel like we're dealing with such complex problems here that is probably the only way to go about it.
Angela.
Well, this is a difficult question to answer. Yeah, I agree with Stefan, but I think we can learn probably from some more traditional industries, such as the aerospace industry, where basically they just do absolutely everything they can ahead of time. From real flight tests to formal verification. So I think we'll need to kind of play with all our tools to get this right. Yeah.
Peter?
Yeah, I mean, I think I agree what was said before. And maybe adding the point we already made several times, I mean, the right to explanation, I think, should be there. One should be able to understand how actions are decided by a robot. And then, I mean, for certain components which are very sensitive, I mean, to my mind, then also sometimes theoretical guarantees might be necessary, in particular when it's very sensitive applications like in the medical sector.
So a lot in the latest discussion around AI systems that we've seen already out in the wild, ethics and value embeddedness and alignment, these are key words that we hear a lot and increasingly many. Do you see sort of a similar threat here to robotics applications, that the system is trustworthy, does always what you think it should be doing, but it does the wrong thing? Is there in the community a discussion around that? And or where do you maybe see the need to enhance the community that we see here?
I think technologically we are still far away from some of these applications where this may be more critical. I guess the closest I can think is self-driving cars. And even then, I do think we can learn from the past, because things like automatic emergency brake was in the car before, is in many, many cars. And there you also have to make a trade-off. If I do an emergency braking maneuver, the car behind me could drive on my car, and that may cause an accident, or I cause another accident. And so I think, while I'm not an expert on this, I think we can also learn from the rules and regulations that are in place already. Yeah.
Great, thank you. Brian, last word to you as a guest to Munich. What is your thought on that? How do we manage alignment?
Well, I think that I think we can go a bit further than just testing, and we should be thinking about presenting these systems in a way that they're accessible to the users that they're interacting with, and ideally that their behavior is modifiable. So to take a less momentous example than a self-driving car, just imagine, there are lots of companies are working on delivery robots, whether they're on the ground or in the air, and we're all going to be, whether we want it or not, we're going to be interacting with those systems. To what extent do we as individuals have agency? Are we just passive observers? And are we just supposed to model what the robot's doing and then work around it? Or can we define those systems in such a way that we're able to actually have some control and be able to modify the behavior of those running systems, like we modify each other's behavior as we interact? I think that's I don't know right now how to get there, but I think it's something that we should be aiming for.
Great. Didn't see any hands up. One more question, two more questions, and then we'll close the panel.
Sure, yeah. So I'm wondering for the practitioners if theoretical guarantees are sufficient or helpful for regulation. So do regulators accept theoretical guarantees, or do you always require to test the model practically to trust on it?
Sorry, it was a question that, can you say that one more time?
You can have theoretical guarantees that give you some trustworthiness of a model, and then can you use that with the regulators to get your model accepted to be used in real cases, or do you still need to? Because in the case of medical stuff, you cannot really test things like that, right? So you would like to have theoretical guarantees that allow you to trust the system, but I don't know if in the regulation side they will actually accept theoretical guarantees as
right. No, I would expect. I mean, honestly, if you look at you can look at functional safety standards, whether it's in medical or in automotive or in aerospace, and the general approach, the general framework is quite similar across all of them. And we would expect that to be applied anytime we're putting a robot system into one of those domains. And so the burden on you as the developer of the system, when you take it to a regulatory body to get, say, functional safety certification, ideally you're bringing a safety case that has both components. You have an analytical component that's giving you some guarantees, but you also have extensive empirical testing, and you're probably always going to have to combine both of those things, I would imagine, unless the theory gets very good, and then we can just rely on that.
Test? Okay. I would like to talk about hallucination. So how big do you think is the problem of neural networks hallucinating things? I guess we currently seeing it in LLMs, like ChatGPT, where they make things up. And yeah, how big do you think is the problem, and would you ban it from robots?
I can maybe say something just from very recent experience. I think in our research, we carefully decide where we use these tools and where we don't, right? Where we rely on more traditional techniques. Let's say if we have a swarm of flying vehicles, we don't want to do any guarantees around collision avoidance and so on based on those tools, but on higher level trajectory generation, we can use them, right? And they may provide some clever paths through a cluttered environment. So I think it's very much about also a design decision where to use these models. I think they're extremely useful in robotics, but at the right places. Yeah.
Great. Anything to add, Stefan?
Yeah, I mean, maybe just to add to it, I think we're also just in the beginning of these sort of generative AI methods, and I agree. I mean, it's kind of stunning how ChatGPT can make up things that sound really plausible, but are absolutely incorrect. I do expect that it's going to get better if we keep working on these sort of things. At least we also have ways to verify in this domain. So I think we should definitely work to move this forward, and again, in the context of explainability, to point out the sources such that we can more directly then verify whether something is incorrect. So, yeah, I mean, I guess I'm not really researching myself in this area, but we should move towards avoiding this, and I think we will be able to get better. That doesn't remove the problem fully, and I also agree with what others said, that when we are employing these kind of tools in robotics, we wouldn't just use them by themselves. We would have all kinds of complementary techniques, perhaps also more traditional ones around them to sort of safeguard from a misbehavior of some sort of AI that's in there.
Great. Gita, you wanted to say?
Oh, just briefly. Yeah, I mean, I completely agree with you. I mean, robustness is a problem, I mean, not only for ChatGPT, but I mean also for AI in general. So for instance, automated driving. And so what was lately also found out is that there could be a problem even with the fact that we use digital hardware and we need to maybe go to other types of hardware like analog hardware to augment digital hardware in a way so that we get more safety. But there's a lot of research going on in that direction, and so I think this will find its way then, I mean, immediately also in the area of robotics.
Great. Well, I think I'm not hallucinating in thinking that we got half an hour allotted for this panel, which we already overstepped a little. And to not entirely lose our trustworthiness, I'm going to close out the panel now. But the panelists will hang around for you guys to ask questions individually and without amplification. So thank you all for coming. I hope you had fun. Thank you.